Here we're going to look at another proportion-related question. Now this time this is about proofs, so we need to show whether or not these statements are true or false. Some of these statements might be some misconceptions about proportion. Let's look at statement part A. If y is directly proportional to x, then y is directly proportional to the square of x. We're going to use that effect for direct proportion, that if y is directly proportional to x, then y over x must be a constant. Now for the second part of the statement, we know that y over x squared is also a constant. However, we can just rewrite this slightly to be y over x times 1 over x, since we can just join these two fractions together, and then x times x is just x squared, which just results to the left hand side. Notice that we know that y over x is a constant, so we can rewrite a constant right here. So we have a constant times 1 over x, which is also a constant based on the second part of the statement. However, notice something right here. We have a constant times an expression involving a variable x is equal to a constant. However, this is a contradiction and this cannot happen. This implies that our original statement right here is false. Now for part B, the converse of statement A is true. If y is directly proportional to the square of x, then y is directly proportional to x. Similar thing, we can use the definition for direct proportion, that if y is directly proportional to the square of x, then y over x squared in this case is a constant, which means that y over x must also be a constant. However, we can just rewrite this, which will be y over x squared times x. And from the second part of our statement, this must also be a constant. Notice that y over x squared must also be a constant as well. And again, here we have a constant times a variable x is equal to a constant. I don't think so. This is a contradiction, meaning that the statement in part B is yet false. Now I will leave part C and part D as a homework for you guys, as the methods used in part C and part D are pretty much the same in part A and part D. Now let's skip to part E. If y is a real number, then y is directly proportional to itself. We can use the definition for direct proportion, that y over y is a constant, and this so happens to be 1, which is obviously a constant, so the statement on part E is true. For part F, it says that y is inversely proportional to itself. So by the definition of inverse proportion, we must have that y times y is a constant. However, this reduces to y squared, which is obviously not a constant since y is a variable right here, meaning that this statement here is false. Now for part Z, if y is directly proportional to x and x is directly proportional to w, then y is directly proportional to w. We can use the definitions of direct proportion multiple times right here. So for the first part, we know that y must be equal to, let's say, a constant k times x. And then next thing, we know that x must be, let's say, constant L times w. Now if we substitute this equation into this equation replacing x, we'll get that y must be equal to k times L times w. We know that k and L are constants, so k times L must also be a constant, which fits into the definition of direct proportion, which means that y is indeed directly proportional to w. And so this statement is true. Now for part H, if y is inversely proportional to x and x is inversely proportional to w, then y is inversely proportional to w. This is pretty much the same thing in part G, except in this case we're dealing with inverse proportions. So we must have that y is equal to k over x for some constant k, and then x is equal to, let's say, L over w for some constant L. We can substitute the value of x into this equation to get y is equal to k over L over w. I'll just put the parentheses here. This will be equal to k times w over L. However, notice that our variable w here is on the numerator instead of the denominator. That means we cannot have y to be inversely proportional to w, and so this statement is false, which ends this video.